See, this is EI, elimination internal. Okay. In this, the first one is the pyrolysis of esters. See, pyrolysis means heating. Okay. Now, let me first give you the basic reaction, then the mechanism. So this is an ester. Okay. Now when this ester is heated, we get ethylene. Along with that, acetic acid. Okay. Now, let's see the mechanism. Let me show you the mechanism. Taking Sahar's projection. So this is the methyl group. Then this. Okay, so this is how I've taken the ester in a way convenient for syn elimination. Remember, in this case, the stereochemistry is a syn elimination, elimination from the same side. Now look at what happens. This particular thing takes away hydrogen. Then immediately this goes here. And of course, the bond comes to oxygen. Or else, straight away, it can be shown this way also. That's it. You get a transition state in the beginning with all the bonds that are going to get broken and that are going to form. You know what a transition state is. Come on. See, this bond is gonna get broken. This is a bond that gets broken. Then here there is a bond already present, and now we are going to get a fresh bond. And see, a bond is going to form between the oxygen and hydrogen here. This one, right? Now, along with this, you got oxygen. And see, the bond between this carbon and oxygen is going to get broken, right? So this is BB. Then look at this. So this is going to get broken. This particular bond is going to get broken. And see, there is this CH3. So this has got all the bonds that are going to get broken and the bonds that are going to get formed. This is what I call transition state. Come on, let us put it in brackets. So this is the transition state. Now this transition state will finally give us, simply decomposes to form, look at this area, this one. Leave the bonds that are going to get broken. See the bond that is forming now. Come on. You get ethylene. Look at this. So this is what you get here. Along with the, see the part that is going to get detached. Look at this area. CH3, C, and of course, let me actually show you this one. See, there is a bond that is going to actually form between this, carbon and oxygen. So you get CH3. See, this area, it gives us C double bond O, and this area is CO H. Check out again. CH3, C double bond O. Then onto this side it is OH. So these are the things that we get. Okay. Now, let me write the byproduct. CH3, C double bond O, then OH. Okay. So this is how the pyrolysis occurs. Okay. So we can actually show it this way also. This O minus goes along with this hydrogen, and this bond goes here. I'm sorry. Let me show you this right from the oxygen. From here I have to show. Yes. This, then this comes here. So that is how you get ethylene. See, in this, we are eliminating things from the same species. So is internal elimination of the two species from the same species, from the same molecule internally. So this is called elimination internal mechanism. Okay. Now, similar ones. We have 3 more of the same type. Let's see them. Now the second one is pyrolysis of xanthates. So this is actually called Chugaev reaction. Okay. Now in Chugaev reaction, first of all, let us see what a xanthate is and what, how a xanthate is prepared. Let us start with ethyl alcohol. Ethyl alcohol reacts with sodium hydroxide. a base, or else you can treat it with sodium hydride also. Upon which you get sodium ethoxide. So this is sodium ethoxide. Okay. Now, this sodium ethoxide reacts with carbon disulfide. Look at this. Let us take it this way. Now it's simple. Minus to plus, minus to plus. O minus with this. Similarly, this minus with this plus. Okay. Now, CH3, CH2, O connected to carbon, which has already got a double bond S, and then this S minus and Na plus, right? Okay, now this is going to react with the methyl halide. Say any alkyl halide, no problem. But here you will have SN2 type of reaction happening. Now, as and when this comes and attacks the unhindered alkyl group of the alkyl halide, this goes off. That is what I told. In SN2, there is always backside attack on unhindered alkyl halide, unhindered 1 degree. That's it. We get CH3, CH2, then O, C double bond S, then that S will now combine with CH3. Sodium halide, of course, is eliminated. We can show that. Right. Now, this on further heating will do the rest of the things. Let me take this CH3 in this format so that I can show you the formation of the product straight away. Same as the previous one. Come on. Yes, this will go off. Okay. So now, the thing what we are going to get is CH2 double bond CH2 plus, of course, within this also, I can actually show you in 2 ways. Okay, take it here. Then this one, of course, goes along with the hydrogen. Yes, in 2 steps. So from that, we get C double bond O onto one side, C double bond S onto the other hand, plus the other product is CH3SH, methane thiol. See, you got your ethylene. And this is what we call xanthate. Pyrolysis of xanthates gives alkene. Okay. Ethyl alcohol is treated with sodium hydroxide or sodium hydride to form sodium ethoxide in the first step. On reaction with carbon disulfide, followed by reaction with methyl iodide, we get xanthate. Now this xanthate on pyrolysis, that means on heating, gives ethylene. Let me show you what happens? Giving the mechanism. Now take the mechanism. The same as what you have seen in the pyrolysis of esters. A similar mechanism can be seen. Again, syn elimination, and of course, Hoffman product. Look at this. Here we have a hydrogen. Let me just put it this way. Okay. Then O, C, we got this, and then this. See, this is the xanthate. That is subjected to pyrolysis. Let us see the steps. First, second, third. Same thing. Right? Now, we get a transition state. Of course, it shows the bonds that are going to get broken and the bonds that are going to form. Okay, then this, of course, these two as it is. Now, this bond is going to get broken, right? Then this one. This is the bond that is going to get formed to be broken. Then this, then this. Now, oxygen, a bond is going to get formed. Come on, this one. This is going to get broken. Right. One more. Yes. This one. So this is the bond that is going to get formed. Right. I've given all the bonds. Now this is the transition state. With all the restructuring of bonds. Now, as usual, look at this area. That is our ethylene. Then the remaining thing, of course, gives us the byproducts. Yes. Let us take the first one, the main product. Ethylene, along with this, of course, we have a bond between SH, then this, only one bond, then C double bond O, then S, then CH3. One second. Yes, this is CH3. And now, okay, let us take this way. This one comes here. The reorganization of the bonds. That's it. This will give us C double bond O, C double bond S. Then the other one is methane thiol. Right? So this is how we can give the mechanism of pyrolysis of xanthates. The formation of xanthates, of course, is given for our knowledge. Straight away, the xanthates on pyrolysis, that means on heating, form ethylene. Okay. Right. See, the next one is scope elimination. See, in scope elimination, similar to the previous two, but of course, the thing taken is different. Consider a 3-degree amine oxide, a tertiary amine oxide. This on heating forms an alkene. Along with that, of course, a hydroxylamine with some substituents. So let me call it a substituted hydroxylamine. Okay, I think you know what hydroxylamine is. NH2OH. We'll have some substitution to this. We'll see how a 3-degree amine oxide is formed in the first step. Then we'll go for the pyrolysis of that amine oxide. Come on, let me take a tertiary amine first. So this is the tertiary amine. Okay. You got nitrogen. A tertiary amine, of course. Now this, in the presence of an oxidizing agent, like you can go for potassium permanganate or something like hydrogen peroxide or even Carros acid, peroxymonosulfuric acid or permonosulfuric acid. Okay, now look at what happens. CH3, CH2, then N. Now, of course, this N combines with the oxygen. You got methyl, you got methyl. Okay. Then, of course, a positive charge on nitrogen because it has only 4 electrons of it as against 5 what it has to have. Right. Now, see, for convenience, let me take it this way. Okay. So this is our 3-degree amine oxide. Now this is going to undergo pyrolysis. Okay. Now, as usual, say this O minus takes away this H in the form of proton. This comes here, and of course, the bond goes to the rescue of the positive charge. Positive charge is neutralized. Now the products, you can see them clearly. You got your ethylene plus a substituted hydroxylamine. Yes, a dimethyl substituted hydroxylamine. Come on. You got OH. Look at this. H. 2 hydrogens have been substituted by methyl groups. So I can tell you that this is dimethyl derivative of our hydroxylamine. Dimethyl hydroxylamine. Hope that is okay. Now let us go for the mechanism. The same time. Again, in elimination, and the product formed is, of course, Hoffman. Come on. H. Then this. We have N plus Me taken twice, then the O minus. Right. Now, O minus attacks. Next step, and this. So very simple. We get a transition state as usual. Come on, let me show you that. H, then this. Right? Now, this is going to get broken. A fresh bond between oxygen and hydrogen. So this is bond formation. Then this is NMe2. Okay, you are going to break this bond. Let me put the positive charge. How about this? This is a bond to be formed. Okay, now this is a transition state. Now this transition state simply decomposes and gives our alkene, that is ethylene. Check this out. The same thing right up to this. This is your ethylene, and the remaining thing is the substituted hydroxylamine. Okay. Yes. Plus NMe2OH. Okay. This is scope elimination. A tertiary amine oxide on pyrolysis gives alkene.